Hello everyone. In the last lecture, we have covered basic elements of digital communication system. Now, come to the next lecture for information theory and coding. Here we will discuss in detail about information and uncertainty, how these are correlated with each other. This is the syllabus which we will cover in the next lectures. And before defining the information, what is signal? What do you mean by signal? Then signal is nothing but anything which can be sensed by some systems. Any system which is sensing something, that something is the signal. That may be meaningful, meaningless, random, those are the signal. Okay. And in that signal we want to put some meaningful things. Okay. For that we will represent some signals through the symbols, so that we can recognize those symbols to form some meaningful things. Okay. Those are symbols. Then we can say this is the signal. Signal. Okay. Then symbol is a subset of a signal. Symbol is the subset of a signal, because some symbols which are only signals, but they have no meaning. Okay. Then some meaningful signals, those may be some symbols. Okay. And a sequence of symbols having some specific meaning, that may be message. Okay. The message, basically the meaningful sequence of symbols formed by some signals. Okay. Now, information, how information and message are correlated with each other. What do you think? Information is same as the message or different? So, basically information contained in the message is meaningful, but it may be meaningful for me, it may be meaningful for others. Okay. And same message having some information for me, but no information for other, or no information for me having some information for others. Same message. Then same message contained different information for different peoples. Okay. Then how can we define information? See, any message, what obvious meaningful, how will it surprise us? The surprisingness in that message, that comes as an information for us. Okay. The same message having no surprise, it has meaning, but there is a no information, like that news, yesterday news already read, we are again reading, it has some message, but there is a no information. Information is already taken. Okay. So, once you have know about it, then information, once you know about it, then information reduces, you may say, like that. Then you may say information is directly proportional to surprise. Information is directly proportional to surprise contained in that message about some event happening. Okay. And surprise that is directly proportional to uncertainty. How it is? How is it uncertain? If it is uncertain and you are getting the message that it is happening, then you get some surprise. If it is certain, if that event going to be happen and it is certain, then that having no surprise. If no surprise, no information. If it is having some surprise, then there is a information. Okay. Then I think you are clear about information, message, symbol and signal. Then here signal, then symbol, then message and then information contained in it. Okay. Then information is the subset of the message, message is the subset of the symbol, symbol is the subset of the signal basically. Okay. Next. Now, information in the common sense. How we define information in the common sense, not in the engineering sense, but common sense. Then as we discussed last that information is directly proportional to surprise. If you are getting some surprise or first time some message you are getting about some events happening, then that contains some information. Okay. If you are getting multiple times same message, then information reduces. Okay. It may be informative for some others who are not getting the message at that time. When they will get the message, they will get the information at that time. Okay. Information and uncertainty with examples, we can see multiple examples like that. Those have some probability. Okay. If they have the probability equals to 1, as I have discussed in the last lecture also, if probability is 1, okay, then information contained in that message of that event, that is tending to 0. Okay. Because that is a meaningful message, but it is certain. If it is certain, then information is minimum. Okay. Then 0 information may be. But if probability is 0, there is 0 probability. Like that sun rises in west, it is 0 probability. But suppose it happens and someone tells you that sun rises in the west today, then probability is 0 and it is happening, you are getting the message, it is true, then that is maximum surprise you will get. Now, how it can happen? Okay. Then you are having infinite information, you are having infinite information in that message, because that is uncertain, its uncertainty is maximum. Okay. Probability is 0 and it is happening, you are getting the message. Okay. Then that message will contain infinite information, maximum information. Okay. And maximum information require maximum words to explain, maximum things you want to express that this is happening. Okay. Now, in engineering sense or commercial sense, this is in the common sense uncertainty. Okay. How engineering sense we can define the information. See, engineering basically commercial sense. Then see, a mobile service provider, you know, how will it cost to you for sending some information to you, okay. And they have no mechanism that this information will surprise you maximum, because that information may surprise, may having some different information for different persons, and information that is very important to us, okay. Then service provider cannot cost as per the information or as per the surprise contained in that message. There is no mechanism to calculate the uncertainty in that message. Then how they can cost, because they know that this message is important to you and this is ultimately very important to you, then they want to cost maximum from you, but they have no measure, you know, of that uncertainty in that message or information. Then we are trying to calculate information in the commercial or engineering sense. See, for an example, there is a source of alphabets A, B up to Z. It is the source, okay. Alphabetical source we know very well, okay. Here we know that every letter has its probability of occurrence. Suppose in a paragraph, okay, in a one page, okay, in a one chapter, if you calculate the number of A, okay, then we can calculate the probability for A, that is the number of times A occurring, suppose that is X A, and total number of letters in that paragraph, page or chapter, that is the total number, okay, suppose T. Then probability of A is nothing but the X A upon T, that is the number of times A occurring in the that paragraph or in that page or that chapter divided by total number of letters. This is the probability of A. Similarly, probability of B, then X B divided by T. B letters, how many times it is occurring in that paragraph, page or chapter divided by total number of letters in that paragraph, page or chapter. Similarly, we can find or calculate the probability for every letter, okay. See, and these but obvious these are not equiprobable. We know that, so like that probability of Q, that is very less, okay. Now suppose we want to send the information using these letters, okay. Here the letter which is highly probable, that is it is occurring multiple times, highly probable, probability is high, then it is occurring multiple times, then multiple times occurring a letter, it should be encoded with less number of symbols, okay, in a common sense, while the letter which is having probability very less, that can be encoded with a larger number of symbols. See, actually, so that there is a one method that we can assign some binary symbol, suppose to each letter equally, that is also one method, okay. Then suppose we are assigning equal number, but here in this case, the case when these are equal number binary symbols we assign, but these are not equiprobable, then we cannot assign equal number of bits because their probabilities are different. Then we have to assign their binary symbols as per their probability. Okay. See, as we know that I is equal to log of 1 upon p, as in the last lecture we have discussed. If you are assigning binary symbol, we can take base 2. Okay. Here suppose for probability of letter A, so I A equals to log of base 2 1 upon P A. Okay. It can be calculated in bits because we are taking the base 2, okay, and P A is the number of P A is the probability for letter A. Okay. This corresponding to its probability of occurrence. Okay. Here we are calculating basically the uncertainty in that, basically the information in that symbol, but it will come in terms of bits. Okay. For example, this may be alphabetical example, we will continue with that. Before that, we take another example. Suppose S0, S1, S2, S3. Okay. With the probability P0, P1, P2, P3. P0 is the 0.5 suppose, P1 is the 0.25 suppose, P2 is the 0.125 and P3 is the 0.125. Suppose there is a source with the 4 outcomes, possible outcomes, with their probability 0.5, 0.25, 0.125 and 0.125. Okay. Here if we calculate the I corresponding to each symbol for their probability using this formula log of base 2 1 upon P0, 1 upon P1, P2, P3, then what we will get? Log of base 2 1 upon 0.5, then 0.5 divided 1 divided by 0.5, you will get the log 2, that is the 1, then 1 number of bits required to represent this symbol 0.25, so log of base 2 1 upon 0.25, then you will get the 1 upon 0.2, that is the 1 upon that is the 4, so log 4 base 2, that is the 2. Similarly, log of base 2 1 upon 0.125, you will get the 3. Basically, these symbols can be represented with these number of bits. S0 can be represented with the 1 number of bit, S1 with 2 number of bits, S2 3 number of bits, S3 with the 3 number of bits. But you calculate its average value, how average information contained in each symbol, then average information in this one, then 0.5 into 1 plus 0.25 into 2 plus 0.125 into 3 plus 125 into 3. It comes as 1.75. Okay. This is the average information in each symbol. While as per binary method, here there are 4 symbols, we can assign 2 bits to each symbol 0 0, 0 1, 1 0, 1 1. If you assign equal number of bits to each, then we have to assign 2 number of bits to each symbol. But if you are assigning the bits using their probability model, we have to assign only 1.75. Then in this example we can say that average number of bits can be lesser. Okay. Now come to the last example, when source A to Z like that, where probabilities are different, then corresponding to each symbol we can give some information in bits, that these bits are required to represent those symbols. Okay. Then that is the engineering sense, we can calculate the bits required to represent that symbol. Okay. And ultimately that will calculate the uncertainty in common sense, but in engineering sense it will calculate the number of bits using the same formula. Okay. And source statistics and source probabilities, that is the probability P1, P2, that is known as the source probabilities, and average information or entropy we can calculate. Next, that is the that will be the first topic part, unit first, entropy, and that we will cover on the in the next lecture. Okay. Whatever we have discussed in the lecture 1 and 2, that is the basic of digital communication to connect the subject, information theory and coding. Okay. This is the first topic of unit first. Okay. That we will discuss in the next lectures in detail. Okay. These are the reference books already told you. Okay. Thank you. Thanking you.